With this video, we're going to understand section 6.4, which is called trigonometric identities. And we have one objective with this section. We want to use algebra to simplify trig expressions. And we're going to also take a look at how we can establish identities. There are some very important identities that we have to know by heart in this lesson. And then this slide shows a summary of the identities that you have to know by heart. So we have quotient identities, which says that tangent of any angle is always its sine value divided by cosine value. So every pre-calc student needs to know this quotient identity. And cotangent, which is the reciprocal of tangent, is cosine over sine. These two are called quotient identities. Then we need to know the reciprocal identities. Cosecant of theta is reciprocal of sine. Secant of theta is reciprocal of cosine. And cotangent is reciprocal of tangent. So these three are called reciprocal identities. Now, my favorite identity in pre-calc is called Pythagorean identity, which says sine square of any angle plus cosine squared of any angle is always equal to 1. This is called the Pythagorean identity. Sine squared plus cosine squared is equal to 1. And then if you play with this main identity a little bit, like by dividing both sides by sine squared, you will maintain the third version of this identity, which is 1 plus cotangent squared theta is equal to cosecant squared theta. If you divide both sides of the equation by cosine squared theta, the identity changes to 1 plus tangent squared theta is equal to secant squared theta. These three are called Pythagorean identities. Even odd identities, and I keep telling this in previous videos, the only two functions that are even functions out of these 6 trig functions are the cosine function and its reciprocal, which is the secant function. So cosine of negative 30 degrees is always the same number as cosine of 30 degrees. Same thing, secant of negative 30 is always the same thing as secant of 30. So therefore, these two functions are called even functions. And then the rest of the other trig functions, sine, cosecant, tangent, cotangent, they're odd functions. So sine of negative 30 is not going to be the same number as sine of 30, but it's just going to be the sign switched. So sine of negative 30 is the same thing as negative sine of theta, and this is the even and odd identities. So let's take a look at what we see on the slide next. So when we are simplifying trig identities, we can use some basic algebra techniques to establish identities. One of these is rewriting a trig expression in terms of sine and cosine only. This is my favorite way. I like to reduce everything to sine and cosine to simplify or prove that they are equal to each other. Number 2, multiplying the numerator and denominator of a ratio by a well chosen of 1. Writing sums of trig ratios as a single ratio, factoring. Those are the 4 techniques. So we're going to apply these 4 techniques with some examples. So here is one of the questions. Using algebraic techniques to simplify trig expressions. Simplify tangent of theta over secant of theta by rewriting each trig functions in terms of sine and cosine functions. So let's just cut this problem. So here, we want to simplify tangent over secant of theta by writing both of them as sine and cosine. So if we go here, so I'm gonna try my best. I don't have a tablet with me right now, but I'm gonna try to show you how I will do this. It just takes such a long time to paste it. Let's try this again, copy, and then I'm just gonna refresh this. And then, yeah, it's right here. So for this question, now, tangent of any angle, so I'm just focusing on this portion. tangent of theta is the exact same thing as sine of theta over cosine of theta. So instead of tangent of theta, I can just write sine over cosine of the same angle. So this only, and as we just discussed a few minutes ago, this is called the quotient identity. All over, so this is the big division line that I'm copying from the main question. Now I need to rewrite the secant of theta in terms of sine and cosine. Secant is the reciprocal of cosine, so instead of secant of theta, I'm going to write 1 over cosine of theta. As you know, this is called also reciprocal identity. So writing the tangent as sine over cosine is called the quotient identity. Writing the secant as 1 over cosine, this is called the reciprocal identity. But anyway, when I keep simplifying what I have in the problem, I'm dividing two fractions. The first fraction is sine over cosine, and the second fraction is 1 over cosine. This is a basic algebra skill to divide two fractions. This is how you divide two fractions. You always copy the first one. So I'm going to copy this one exactly the same. So I have sine theta over cosine theta. This is the first fraction. And then we always change division to multiplication, and then we flip the second one over. So I need to copy the reciprocal of the second one, which will be cosine of theta over 1. So this is how we divide two fractions in algebra. Copy the first one, multiply it by the reciprocal of the second one. When I set this up like this, the top cosine of theta and the bottom of cosine of theta cancels each other because we are performing a multiplication. When I see the same factor at the top and same factor at the bottom, they cross out. So the only thing left at the top is sine of theta. The only thing left at the bottom is 1. So sine over 1 is just sine of theta. This is how we solve these questions by doing this. So if we go back to the slideshow, we had these 4 problems, and then that's exactly what they did on the presentation. Instead of tangent of theta, they wrote sine over cosine. Instead of secant, they wrote 1 over cosine. And then when they are dividing two fractions, copy the first one, multiply it by the reciprocal of the second one. And this is how you get the answer for the first one. Now, the second question is, I want to now copy the second question. It's a given relationship. And then here, I want to clear this plane and then put this question here. And then we're going to read the question together again. So show that sine of theta over 1 minus cosine of theta is the exact same thing as 1 plus cosine of theta over sine of theta by multiplying the numerator and denominator by 1 plus cosine of theta. So they're nice that they're telling me what technique to use, which will not be the case all the time. So we have to show them that first side of the equation is exactly the same as second side of the equation by multiplying top and bottom by 1 plus cosine of theta. So we're going to multiply first part by 1 plus cosine of theta. So I'm multiplying one side of the equation. I have to make sure that I'm also multiplying the other side of the equation. So this is also 1 plus cosine of theta. So here, we're going to have to multiply numerator and denominator. So the numerator is sine of theta. And then we're multiplying it by 1 plus cosine of theta. And then the denominator is, we already had the 1 minus cosine of theta here. And now we're multiplying it by 1 plus cosine of theta. Actually, I think I'm just going to go ahead and take the first portion of this equation and do the necessary work to see if I can get the exact same thing on the right side that I see. So here, sine of theta times 1 is just sine of theta plus sine theta times cosine theta times cos theta all over. Now this is the tricky part. This is called difference of two squares. So when I multiply 1 minus cosine of theta by 1 plus cosine of theta, I always get 1 minus cosine squared of theta. I know this because I know the factoring rules very well. But if you don't believe me, you can do the long way. You can FOIL them and you're going to see that the negative cosine theta and positive cosine of theta, they cancel each other. And then you will end up with 1 minus cosine squared of theta. I can continue to simplify what I got here. So at the numerator here, when I look at what I have the sine of theta plus sine theta plus cos theta. They do have a common factor. Their common factor is sine of theta. So I'm going to factor out the sine of theta. And then open parentheses, I'm going to place a 1 because 1 times sine of theta is just sine of theta plus. And then if I put the sine of theta of the second expression outside of the parentheses, we're going to get cosine of theta. So sine times 1 is just sine. Sine times cosine is sine cos. All over 1 minus cosine squared is going to give me a sine squared theta because of the Pythagorean theorem. So if you remember the main identity, if sine squared plus cosine squared is equal to 1, and then in that main identity, if you isolate the sine squared is always equal to 1 minus cosine squared theta. So when I see 1 minus cosine squared, I can simply replace it with sine squared of theta. So here, these two will cancel out. So we're going to get 1 plus cosine of theta at the numerator. And then 1 power of the sine will be canceling with the top. So we're just going to get the sine of theta here, which is the exact same thing as the right side. And the third one we are going to look at here is using algebraic techniques. We will try to simplify this by factoring. So we're going to go ahead and look at this one next. All right, so we have cosine squared theta minus 1 all over tangent of theta times cosine of theta plus tangent of theta, and we want to use factoring. Okay, so if I look at cosine squared of theta minus 1, I want to show you here as an extra, this is something very important in algebra, in math. If you happen to know that anytime you have something looks like a squared minus b squared, and you need to factor something which looks like something squared minus something squared, answer will be always a plus b times a minus b. So this is a very important factoring rule that if you know, it's going to be very useful for me for a lot of question types. Therefore, when I look at this question, I do recognize that cosine squared theta minus 1 looks like this expression I have over here, where a value is cosine of theta and b value is 1. So I can use the formula in order to factor it. I need to write cosine of theta plus 1 times cosine of theta minus 1. That's how we use factoring to change this expression to two different factors all over Now at the denominator of this expression, I'm going to use factoring by GCF. So the first expression is 10 times cos, and the second one is just 10. So I know that they both have a tangent of theta as a common factor. So we're going to have to separate tangent of theta from the expression. So I'm factoring out tangent of theta. So I have a cos theta left from the first one, plus, because this whole thing, I copied it to the outside, so I'm just gonna put a 1 here. I can always check my factoring. So when I multiply these two, they give me tangent of theta times cosine of theta. And when I multiply tangent of theta by 1, I just get a tangent of theta. Now, if I do a same factor at the top and bottom, I get to cancel them. So I'm going to cancel cos theta plus 1 by cos theta plus 1. So the numerator just becomes cosine of theta minus 1. And then the denominator is just tangent of theta. This is how I can simplify this question by using factoring. So I'm going to take you guys back to the slide. And then on the slide, that's the work they have done here. And then they got the same answer as we did. Establishing identities for this lesson is kind of the same thing as using all these techniques and proving that the first side of the equation is exactly the same as the second side of the equation. For example, the example they have here is cosecant of theta times tangent of theta is equal to secant of theta. To prove that these two are equal to each other, they took the most complicated version and they changed the cosecant of theta as 1 over sine of theta because that's what cosecant is equal to. Cosecant is always reciprocal of sine. And instead of tangent, they wrote sine over cosine. So the top sine value and the bottom sine value, they cancel each other, and then they just get 1 over cosine of theta, which is the same thing as secant of theta. Therefore, they prove that the first side of the equation is equal to the second side of the equation. Now, here is sine squared negative theta plus cosine squared of negative theta is equal to 1. This one is more complicated, I guess, because we have the main identity where the angles are not negative. So here's the explanation. With the negative theta, they realize that they can use the even odd identities. With even and odd identities, sine squared of negative theta is the same thing as taking the sine of negative theta and squaring it. Similarly, cosine squared of negative theta is the same thing as taking the cosine of negative theta and squaring it. Because cosine is an even function, so having a negative angle doesn't mean anything. It's the exact same thing as cos theta, so they're able to replace cosine of negative theta with cosine of theta because cosine is an even function, so this negative doesn't make any change. However, sine is an odd function, so the negative in front of the angle needs to move to the front of the expression. So sine of negative theta is the same thing as negative sine of theta, but we are squaring this because of the expression we are given. So which turns out to the same thing as sine squared theta, and then this is already cosine squared theta, and using the Pythagorean identity, we know that they're going to add up to a 1. So there is more questions here about proving identities, and with this lesson, each question is unique to itself, and they're just showing us some examples here. And on the homework, you might even have a problem that you haven't seen a sample here, but by troubleshooting, researching, understanding how that needs to be handled, you're gonna learn how to handle that question. So for example, this one here, what they are doing is they kept the numerator the same, but instead of cosecant, they wrote 1 over sine. And then they try to write this as a 1 fraction. So they kept the numerator the same, but adding 1 and 1 plus sine of theta, you need to get them in common denominator. So if you write the 1 as sine over sine, the denominators will match. So this whole thing will change it to a sine theta plus 1 all over sine of theta. Now we're back to the fraction division, which is copy the first one, this is the first one, multiply it by the reciprocal of the second one. So if you flip over the second one, these two same factors will cancel out and you're going to end up with sine of theta. As you understand with this lesson, your algebra skills needs to be really in good shape. And then you need to know how to convert these trig functions among each other so you can understand these question types. And then the homework might have more problems than we see here. And um, I want to finish this video by talking about the guidelines for establishing identities. It is almost always preferable to start with the side containing the more complicated expression. Rewrite sums or differences of quotients as a single quotient. Sometimes it will help to rewrite one side in terms of cosine and sine functions only. Always keep the goal in mind as you manipulate one side of the expression. Keep in mind the form of the expression on the other side. And then this lesson is going to get better with a lot of practice questions. So feel free to regenerate the problem while you are doing your homework, even though you get the answer right. This is it for section 6.4. Bye.